Hello rock stars. Welcome to School Revise. In a world full of confusing maths chapters, the one chapter that rules them all is Chapter 1, Real Numbers. And today, let us crack it open together. Ready? Rock stars. Let us go. And focus up, and let us absolutely smash this. The one chapter, 15 minutes. And the power to walk into your board exam knowing exactly what to write. That is what we are doing today. We have 3 things to master today. Number 1, Euclid's division lemma. This is the shortcut that finds HCF in seconds. Number 2, the fundamental theorem of arithmetic. The most beautiful theorem in the whole NCERT, in my humble opinion. And number 3, the proof that root 2 is irrational. Now this is the one that comes in board exams almost every single year. So sharpen your pencils, open your notebooks and NCERT textbooks to practice, and let us begin. Before we dive in, let me show you what real numbers actually are. Look at this number line. Here you see the integers -3, -2, -1, 0, 1, 2, 3. These are the whole numbers, positive and negative numbers. But the real numbers are more than just integers. They include fractions, 1 by half, 7 by 4, -3 by 2. These are called rationals. And they also include numbers like root 2, -√3, and pi. Numbers that cannot be written as simple fractions are called irrationals. Here, every single point on this line is called as real number. Every number belongs to a family, and families live within families. Now watch carefully. The biggest family is R. All these are called real numbers. Inside it sits Q, the rationals. Inside that sits Z, the integers. Inside that sits W, the whole numbers. And at the very center is N, the natural numbers, 1, 2, 3, and so on. Every natural number is also a whole number. Every whole number is also an integer. Every integer is also a rational number. And every rational number is a real number. So the smallest family, naturals, is part of the biggest family, reals. Today we are going to study the properties of that biggest family. Let us begin. Euclid's division lemma. The name sounds very fancy, doesn't it? Lemma sounds like something only PhD professors should know about it. But trust me, you have been doing this since you were in class 3. You didn't know it had a name. Now let us watch this. Let us imagine that you have gone to the local market early in the morning. The fresh smell of vegetables, the sound of bargaining, the vendors calling out, you know that scene, right? Now there is a fruit vendor in front of you. He has 17 mangoes. Beautiful, golden, ripened mangoes. And now, he wants to pack them into baskets of 5. Quick, now let us pause the video. How many baskets? And how many mangoes left over? Don't peek. Got it. 3 baskets of 5, that is 15 mangoes packed. And 2 mangoes left over. Maybe the vendor eats those. In mathematics, we just write this whole story as 17 is equals to 5 times 3 plus 2. That's it. That is the Euclid's division lemma. Now formally for any 2 positive integers a and b, you can always find unique whole numbers q and r, so that a is equals to b, q plus r, where r is between 0 and b. Now let us look at this carefully. A is the dividend, what we are dividing. B is the divisor, what we divide by. Q is the quotient. And R is the remainder. C. Same mangoes problem. just dressed up in formal language. Now, this is where it gets beautiful. Let me show you how to use this lemma to find HCF, highest common factor, of any two numbers without prime factorization. Faster and cleaner. Now let us watch this magic. Let us find HCF of 96 and 60. Step 1. Divide the bigger number by the smaller. 96 by 60. 96 is equal to 60 times 1 plus 36. Step 2. And this is the trick, listen carefully, take the divisor and the remainder. 60 and 36. Divide again. 60 is equal to 36 times 1 plus 24. Keep going. 36 by 24. 36 is equal to 24 times 1 plus 12. Almost there. 24 by 12. 24 is equals to 12 times 2. Plus 0. The moment you get 0 as remainder, stop. The divisor at this final step is 12, so that is your HCF. HCF of 96 and 60 is equal to 12. Done. No factor trees. No struggle. Just division, division, division. Now between you and me, quick exam tip. Listen carefully. When the board exam asks for HCF using Euclid's algorithm, write every single step. Even the boring ones. Each correct line carries marks. If you skip steps, you might lose 2 marks for nothing. So show you're working. Always show you're working. Got it? Now, we come to my favorite theorem in the whole NCERT. The fundamental theorem of arithmetic. The name says fundamental for a reason. This theorem is the foundation. The bedrock. Without this, half of number theory falls apart. But the idea is so simple, so beautiful, you will wonder why no one told you sooner. Here it is. Listen carefully. Every composite number, every single one, can be written as a product of prime numbers. And this prime factorization is unique. Except for the order of the primes. What does that mean? It means every number has its own secret recipe of primes. Its own DNA. No two numbers share the same prime DNA. Sounds abstract. Let me show you with 12. 12, now let us break it. But how? Maybe 4 times 3. Okay. Now let us break the 4, that is 2 times 2. Stop. 3, 2, 2. We have reached the primes. So 12 is equals to 2 times 3, or, in shortcut, 2 squared times 3. Now here is the magic. You could have started differently. Started with 6 times 2. Then, 6 as 2 times 3. Same primes. 2, 2, 3. No matter how you start, you always land on the same primes. Always. That is what unique means. Now let us use this theorem. Find HCF and LCM of 18 and 24. Prime factorize both. 18 is equals to 2 times 3 squared. 24 is equals to cube times 3. For HCF, common primes, smallest powers. Common primes are 2 and 3. Smallest powers, both to the power 1. So HCF is equals to 2 times 3, which is 6. For LCM, all primes, biggest powers. 2 cubed times 3 squared. That is 8 times 9. Equals 72. And now the beautiful part. The formula every CBSE examiner loves to test. HCF times LCM equals the product of the two numbers. Verify, 6 times 72 is equals to 432. And 18 times 24 also is equals to 432. Same answer. 100% match. If your final answer doesn't satisfy this formula, red flag. You have made a mistake somewhere. Always verify. Okay guys. Now let you guys pause everything. If you are chatting with friends, scrolling reels, eating snacks, just pause right now. Because what I am going to teach you in the next 3 minutes has been asked in CBSE board exams almost every single year for the last 20 years. The proof that root 2 is irrational. If you understand this proof, you can also prove root 3, root 5 and root 7 are also irrational. Same logic. Same template. Just change the number. So, pay attention. Watch this section twice if you need to. First, a tiny tool. A baby theorem. Takes 1 minute. But without it, our main proof doesn't work. The Euclid's division lemma says, if P is prime and P divides A square, then P must also divide A. But why? By the fundamental theorem we just learned, any number A can be written as a product of primes. Say A equals to P 1 times P 2 times up to Pn. Square it, A square is equals to P 1 squared times P 2 squared and so on. Did you notice, squaring doesn't bring in any new primes. Same prime factors, just doubled up. So if P divides A square, P has to be one of these primes. Which means P divides A. 2. Done? Simple, right? We have got our weapon. Now, let's go. Now, the technique we are using is called proof by contradiction. Sounds intimidating, right? Idea is simple. We assume the opposite of what we want to prove. We follow the mathematics step by step. And we watch the assumption fall apart in our hands. When the assumption falls apart, we know it must have been wrong from the start. So the original statement was true. Like this, imagine I tell you, I am going to wake up at 5 a.m. tomorrow. You assume I will. Alarm rings, but I don't get up. Reality contradicts. Assumption was wrong. So, now let us prove root 2 is irrational. Step by step. Step 1. Let us assume, just for the sake of argument, that root 2 is rational. Step 2. If root 2 is rational, then we can write it as P over Q, where P and Q are integers. Q is not 0. And P and Q have no common factor. They are fully reduced. Coprime. Like 3 over 7, but not as 6 over 14. Step 3. Square both sides. 2 equals P square over Q square. Cross multiply, P square is equals to 2, Q square. Now look carefully, P square is equals to 2, Q square. The right side has 2. Multiplying everything. So, P square is even. By our baby theorem, if 2 divides P square, then 2 divides P. So, P is even. Step 5. P is even, write P as 2. K for some integer, K. Substitute back. 2. K whole square is equals to Q square. 4K square is equals to 2, Q square. Divide by 2, Q square is equals to 2, K square. Step 6. Same trick again, Q square is even. Therefore, Q is even. Step 7. Look at where we started. Step 2. We said P and Q have no common factor. And what did we just prove? P is even. Q is even. Both even. Both share the factor 2. Contradiction. Right? Our beautiful assumption that root 2 is rational has fallen apart in our hands. It cannot be true. Therefore, root 2 is irrational. Hence proved. Beautiful, isn't it? Beautiful proof. And remember, same template works for root 3, root 5, root 7, root 11. Practice the 7 steps. You have handled this question for life. Okay, champions. Time to apply what you have learned to real board exam style problems. I want you to pause the video, try them yourself first. Then watch the solution. Promise me you will try first. Practice more. Problem 1. Find the HCF and LCM of 72 and 120 using prime factorization. Pause now and try. Ready? Let's solve. Step 1. Prime factorize. 72 is equal to 2 cube times 3 square. 120 is equal to 2 cube times 3 times 5. Step 2. HCF. Common primes, smallest powers. Both numbers have 2 cube and 3 common. So HCF equals to 2 cube times 3, that is 8 times 3 equal to 24. Step 3. LCM. All primes, highest powers. 2 cube, 3 square, and 5. So LCM equal to 8 times 9 times 5, that is 360. Step 4. Verify. 24 times 360 is equals to 8640 and 72 times 120 is also equals to 8640. Match. Answer correct. HCF is 24, LCM is 360. Problem 2. Slightly trickier. Prove that 5 minus root 3 is irrational. You are given that root 3 is irrational. Pause now and try. Watch how I attack this. Step 1. Assume the opposite. Let 5 minus root 3 be rational. Just for argument's sake. Step 2. If rational, then 5 minus root 3 equals p over q. Sum integers p and q. Step 3. Rearrange. Take root 3 to one side. Root 3 equals 5 minus p over q. Combine fractions. Root 3 equals 5q minus p, divided by q. Step 4. Now look at the right side. Integer minus integer, divided by integer. That is rational. Step 5. But we were given that root 3 is irrational. So we have rational equal to irrational. Impossible. Contradiction. Our assumption was wrong. 5 minus root 3 is irrational. Hence proved. C. Same template. Assume opposite. Show contradiction. Conclude. 3 moves. Every irrationality proof. What a journey, students. Quick recap. Tick number 1. Euclid's division lemma. A equals to B, Q plus R. Your shortcut to HCF. Tick number 2. Fundamental Theorem of Arithmetic. Every number, unique prime DNA. Tick number 3. Proof of irrationality. 7-step contradiction. Works for any prime root. 3 things. That's it. Practice and try to understand the concept. You have nailed Chapter 1. Coming up next. Chapter 2. Polynomials. We will learn the secrets of finding zeros, the division algorithm, and how to draw a parabola in 2 seconds flat. Trust me, polynomials is where the real fun begins. If this video helped you, even one thing clicked, even one doubt cleared, please hit that like button. It really helps the channel grow. And helps your friends discover this video too. Subscribe to School Revise. Every chapter, every concept, every shortcut for Class 10, coming free, straight to your home. And visit schoolrevise.com. free worksheets, virtual labs, practice tests, everything you need. But most importantly, promise me this. Today, right now after this video, open your NCERT and try the exercise problems. 5 problems, minimum. Mathematics is not learned by watching. Mathematics is learned by solving. Go. Practice. Excel. Take care, study hard, and I will see you in chapter 2. Goodbye.